Welcome to module 3.4. In this module, we'll take a little bit of detour from what we have been discussing, and the idea here is to familiarize with rootkits, which is actually a common threat today, and it's basically a package of malware that is used to take over a machine or take over a phone and things like that. And we have couple of submodules in this. The basic idea is that we want to tell you what a rootkit is, and then we'll talk about different classification of rootkits, user mode, kernel mode, and then we'll talk about how detection of rootkits can be done, and then how to recover from rootkits. So first the basics. So what is a rootkit? It's a collection of tools that are installed, and how it is installed depends on what kind of exploits are used. For example, it could be through a buffer overflow, it could be by compromising the password, or it could be some other privilege escalation attack. But overall, the idea is to install a number of tools to get access to your machine, and then in order to hide the footprint of the attacker, they actually install tools that will do cleaning of logs, for example, or turn off logging, process, file, user, hiding tools, installing network sniffers, and installing trojans or backdoor programs to connect to a command and control center. So the goal of a rootkit is to remove evidence of the original attack and whatever activity the malware is doing, hide future activities, which is if it is creating a new file or it is creating network connections, new processes are launched, those are to be hidden, and logging is prevented, and that enables the attacker to be in your system without being detected. And so that also widens the scope of penetration, because once it is taking over your machine, it can do a lot more things in the network itself. And also they want to secure the system against other attackers, so that they have full control over the machine they have already gained control of. So concealment techniques by a rootkit is to remove the logs and audit file entries, or turn off the logging capabilities, modify system programs to hide attacker files, network connections and processes, modify logging system to not log specific activities but keep logging other activities, so that you are fooled into believing that everything is fine. Sometimes it can modify the system calls to hide the activities of the attacker. So installation concealment is done by using subdirectories which are pretty busy subdirectories, like /dev/ etc /lib, userlib and so on. So there are so many files in those subdirectories that if it creates temporary directories there for installation purposes, you may not be able to see it. Use dot files which are not shown by an ls. And sometimes they use dot tab or dot blank space, dot blank space, which look like expected dot files that are usually in the system. Also use file names that systems might use, for example dev/hdd libx.a, and then and sometimes these files are not important for your specific system, so they can actually change the file and you wouldn't notice it. And then eventually it will install, it will delete the installation directory, so that you don't find its activities later. The attack tools that it would like to install would be something like a network sniffer, a keylogger, a password grabber, password crackers, vulnerability scanners, so that it knows it can scan the vulnerability of your existing program so that it can do further attacks. And then there is a special class called auto routers. So they are actually the one that are most common these days, which is not so much there is not so much manual activity, like first exploit and then install something and then SSH into a server and then get more tools and things like that. So autorouter does all these things using a script, and then DDoS tools, like for if they're recruiting your machine for a DDoS attack, then there would be DDoS tools. So the history of rootkits goes back to 1989, and it's been evolving since then. And first Linux rootkit was in 1996, and it's still going on, and many times you see that an existing rootkit is comes back with modification. And then we talked about subvert in the previous module, where we talked about a rootkit that can actually even lift your OS over a VM without through virtualization, and you wouldn't even notice. So the first sub module, what are the types of rootkits? So there are user mode rootkits. So they replace normal user programs like ls, netstat, ps with their version. So when you do a ps, you will not see the processes. They filter the processes that they are creating. Trojan backdoors like login, SSHD and so on, and then they could actually replace system libraries, and so that they are basically wrapped system libraries, and they will do certain things before actual system library is called. Kernel rootkits, they modify system call structures so that all user mode programs use, and then add backdoors to the kernel itself, which is quite more dangerous. So there are binary rootkits. They will actually install common programs with their versions like ls, netstat, ps and things like that, so that when those things are used to check system state, they are going to show different things. So they also install programs that will edit the loggers and accounting files, and then login, password, SSHD also are replaced by their version, and they might also install network sniffers to look at the network activities, and since they are in your system, and if your system is communicating with servers and so on, they can actually use a lot of this information for various purposes. So Linux rootkit LRK v4 has all these programs that are commonly used by users in Linux, replaced in the Trojan with the Trojan version. They also if config, for example, doesn't show promiscuous mode for the network listening, and therefore it would be actually capturing all communication rather than just the one that are distinct for that particular MAC address. Login, ls, password, ps, rshd, syslogd, all these things are replaced by various versions that are used to check what processes are running, what files are created and things like that. So normally the one way to detect the binary rootkit is to actually use some known good tools from a CD-ROM and then use that to run the system commands such as ps and so on, and then check the match between the outputs of those with the output that you get by running the ps, for example, on your system itself. And if that turns out to be different, then you know that something is wrong, and then you have to somehow clean your system. You can do various file integrity checks so that you can check whether something is different from where the system should be. Library rootkits, for example, Thorn rootkit that was originally designed in Netherlands. They actually use libproc.a system library, and they replace that, and basically also they modify the libc. So instead of calling the normal libc functions, you basically are at their mercy, and they will actually first, since they put a wrapper around these calls, so they will intercept the calls and then decide what is returned back to the user program. So if the user program is meant for checking various system state information, they actually can fool the program by returning wrong information or stripped down information. Now kernel rootkits, since the kernel runs in the supervisor mode, so they have complete control over machines, and therefore if such a rootkit affects your system, then a lot more damage can be done. So for example, execve can be modified through so you will then it will run when you actually make a call to execve, it might run something else. Even it can subvert your integrity checker and so on. Set UID status of files may be modified so that when a user run that program, it becomes actually root root privileged, and therefore then the program the rootkit can get root access by compromising that program. So the stealth provided by this rootkit actually compromises file integrity checkers. All programs can be impacted by Trojans, and this might open backdoor or sniff network traffic onto your machine and so on. So sometimes these Trojans are actually part of the normally binary that you would normally invoke as a user, and they actually have changed it, and they have somehow fooled the integrity checker, and therefore you are running your program as well as their Trojan programs. So so there are so these things, kernel rootkits actually can come in many forms. So for example, they may come as a loadable kernel module, what we call LKMs. So for example, device drivers are LKMs, and so one can actually defeat them by disabling LKMs, but that disabling something does not necessarily make things easy for you, because you might actually need it for your system. So that is not necessarily always a solution. Alter running kernel in memory. So sometimes they can actually modify, for example, this file, which basically keeps an image of the currently loaded memory. So somehow make you page out, and then they change this, and then they want to page in, and then you are actually going to get a wrong version of things. And it might also alter the kernel on the disk. So next time you boot, you might actually be infected. So so detection normally would be that you want to list the kernel modules and examine the kernel symbols, but this is quite difficult and involved, and sometimes you have to actually check the system call addresses, and but many of these things can be hidden or forged. Therefore you may have to actually use a like a bootable disk or something to actually get a clean version of various tools, and then check the system. Narc is an example of a Linux based LKM rootkit. So it does many of these things like hide or unhide files or directories, hide TCP and UDP connections. It may do control hijacking. It can do privilege escalation by changing the SUID state of a file. It can change the UID and GID of a running process, and so on and so forth. So and then there is an assistant LKM that hides narc from module listing attempts. Now we are going into the rootkit detection. So one is that you can do an offline system examination. So which means that you mount and examine your disk using another clean OS kernel and image, or use Knoppix live CD Linux distribution. You can also do forensics, examine the disk below file system level. So, for example, Helix is a live CD Linux forensic tools. There are also the other utilities such as check rootkit, and it can detect a number of different rootkits. It can check for commonly Trojan binaries, examine log files for modification, checks for LKM rootkits, and you can use -p option to use known safe binaries from the CD-ROM. So you can compare the results of the binary that is in your system versus what's in the what the CD-ROM one on the CD-ROM is going to give you. Carbonite is another tool. It's actually an LKM itself. It searches for rootkits in the kernel, and it generates and searches frozen image kernel process structure. So you can actually examine that for checking for any strange things. So the countermeasures, rootkit designers, they will try to hide the rootkit in unused sectors or unused fragments of used sectors. They might install it in a flash memory like PC BIOS, and that basically means that even after the disk formatting and OS reinstallation is done, if it is in the BIOS, then it will actually remain persistent. So recovery from a rootkit, you have to restore the compromised program from the backup. Obviously if you do that, you will lose the evidence of intrusion, and the question always remains that did you find all the Trojans. Always backup system and then restore from tape. So save image of hard disk from investigation, and restore known safe image. So Microsoft automatically does it, and patch system to repair exploited vulnerabilities. So the key points are that backdoors allow intruder into the system without using the exploit again. So once it has to get an exploit to get into the system, install rootkit, and it deeply compromises the system, and root access is attained. They are easy to use, difficult to detect. And you cannot trust anything on a compromised system. So you have to access the disk from a known safe system like a Knoppix CD. Recovery requires a full reinstallation of the OS, restoration of files from known good backups, and if it is in the BIOS, then even that won't work. So there are a number of references. So it's very important that if you are wanting to do something in cybersecurity, you have a good knowledge of how the rootkits work, and then how these things can be detected and so on. So this might be actually a good list to keep in order to reference.